increasing and decreasing functions. They have an odd definition. It's a very, very mathy definition. But if we look at it graphically, it's a little bit easier to understand. So this is an increasing function on the interval from A to B. Note that it is an open interval. It does not include the endpoints. Reasons for that would be, or perhaps easiest to interpret it as, well, at an endpoint you're not really going up anymore. You're also not going down anymore. So endpoints are never included. If you do go on to calculus, you'll get a better explanation of that. But the definition of increasing, it's described many ways, but basically what it boils down to is that the average rate of change is positive no matter what 2 points you pick within this interval. Now, it doesn't have to be the end points. It can be any 2 points. So for example, suppose I chose a point here and a point here. If I were to connect those 2 points with a line segment, that line segment would have a positive slope. How do we know this? Well, we have 2 ordered pairs. We'll call this x sub 1, and its output value then is f of x sub 1. And we'll call this point then x sub 2, and its output value is f of x sub 2. Now, the points can be labeled either way, and you will get the same result, but the fact of the matter is that it's easier to work from left to right. So the point that's further to the left is x sub 1, and the point that's further to the right is x sub 2. The average rate of change for this then is the difference in the output values over the difference in the input values. But what we have to keep in mind here is that, first of all, f of x sub 2 is higher than f of x sub 1. That means it's a larger value. And whenever you take a large value and subtract a smaller value, you always get a positive result. The same thing can then be said of the x values in the denominator. Since x sub 2 is further to the right, it is larger than x sub 1. And again, larger minus smaller always results in a positive value. So no matter how you slice it, whether you look at it as the slope of the line segment, whether you actually look at the calculation of it, the idea is that for these 2 points, the average rate of change is positive. Now, it doesn't just stop there. The definition says that it has to be true for any 2 points chosen within this interval. So let's try a different set of points. It can be any 2 points you can think of. Maybe they're close together, maybe they're farther apart. But no matter where we choose them, the line segment connecting them will always have a positive slope. It will always be rising from left to right. Here's another pair of points. In this case, the line segment is almost on top of the actual graph. Well, again, that's not really relevant. The fact of the matter is that, again, the line segment has a positive slope. And it can be from something all the way at the beginning to something all the way at the end. It will still have a positive slope. any 2 points you choose on here, any two, will have a positive slope between them. In much the same way then, a decreasing function will always have a negative slope, no matter what 2 points you choose. So this time, in order to be decreasing, it should be going something more like this. So that whatever 2 points on it we choose, the line segment connecting them always has a negative slope. Again, if we do x sub 2 as the point further to the right and x sub 1 as the point further to the left, then we have, again, in the denominator, large minus small is positive. But now, f of x sub 2 is smaller than f of x sub 1. So in the numerator, we have a small value minus a larger value. And that always results in a negative answer. So a negative slope, a negative average rate of change. Once again, this can be true for any 2 points that we choose in this interval. They can be close together, far apart. They can both be towards the beginning, both towards the end. They can be spread out anywhere along it. The line segment connecting them will have a negative slope every time. Now, why does it need to be, why does it need to be both points are within the section where it's decreasing, or both points need to be in the section where it's increasing? Things get a little wonky if you get to extend beyond that. So let's take a look at a graph that's a little bit more complete, that has some section where it's increasing and some where it's decreasing. We'll take a simple parabola. Let's take a parabola now. As we move from left to right, we have a section where, if we choose any 2 points on it, the line segment between them will be positively sloped. And that will continue until we reach the very top. I can pick any 2 points on the left side of this. As long as both are on the left, there will always be a positive slope between the points. Once I pass the top, the graph moves downward from left to right, which means that any 2 points I pick over here will have a negative slope when I connect them with a line. So, are we allowed to cross over that that point at the very top? No, actually, because wonky things kind of happen there. If I am allowed to cross it, I could have a line segment with a negative slope, but depending on where I put that other point, I might have it with a positive slope. That's really kind of confusing. That's very inconclusive, and that's part of the idea, is that both points have to be within the section where it's increasing, or both points have to be within the section where it's decreasing. If we allow the points to be one from one part of it and the other point from the other part, we can get mixed results, and that doesn't help us in any way. So, the idea then is that the function, the graph, breaks down we'll call that C. It breaks down then into two separate sections. Everything from the left side up to C will qualify as increasing, because as long as we stay on this side, any 2 points we choose on this side, the line segment connecting them will have a positive slope. Any 2 points. But we have to stay on the left side for it to work. Likewise, as long as we stay entirely on the right side of this graph, any 2 points we choose on this side will always have a negatively sloped line segment connecting them. So, what we can say then is that this function is increasing on the interval of the x-axis from negative infinity up to c. That is this section of the x-axis. It is, however, then decreasing on the section of the x-axis from c to positive infinity.